All right, hello everybody. I'm gonna have the question linked as well, but today we're gonna do one example of how we can find the time, half-life, and concentration when you're given a certain drug, as well as the elimination rate constant. So this is the question that I have. It goes by: a 1 gram IV bolus dose of a drug was administered at 21:45 on 9/15. Two concentration after the dose were 21.9 micrograms per ml at 12:14:26 on 9/16 and 13.5 micrograms per ml at 16:52 on 9/17. So first we're gonna calculate first we're gonna go ahead and calculate K, which is the elimination rate constant. So we have an equation that we typically use. So K equals ln of the initial concentration C1 divided by the last concentration C2 divided by time t. So essentially our initial concentration is going to be 21.9 and the second one is going to be 13.5, and the time is going to be the time difference between 14:24 and 16:52. So essentially, you know how this is military time, so this is going to be 14:26. It's going to be the same as 2:26, and this will be PM, and it's going to be 16:52 is going to be 4:52. So when you go ahead and calculate the time difference, it comes out to be 26.4333 hours. So then this is at this point you just have to kind of plug it in. So K equals ln. The C1 is going to be 21.9 divided by 13.5, all divided by the time, which is the difference between the ones I just told you about, and that'll be 26.433 hours. So when you do the math, K comes out to be 0.0183 hours inverse. So we got K. So once you get K, we can go ahead and calculate the T half-life, which will be T half-life is going to be B. So let's go ahead and do that. So B is going to calculate T half-life, and that will be the formula is going to be equals 0.693 divided by K. So now we got K, just plug it in. 0.693 divided by 0.0183 hours inverse, and that comes out to be 37.8 hours. Alright, and C is going to be, we're going to calculate the initial concentration when a dose was given. So to do this, we have a special equation that we use. That will be C1, which is going to be C0 equals C2, which is the second concentration, divided by e to the negative kt. So essentially, when you get to do this problem, actually, it's better for me to draw a graph. So I'll go ahead and draw a graph, and this is going to be C0. It's going to be about right here. C0 is I'm going to represent C0 as C1. So we're essentially trying to find this concentration when a dose of 1 gram was given. And to find this, you're going to have to find the first concentration that it took at time 14:26, which will be 21.9. This is what we're going to use. So now C2 is going to be 21.9. Now we have the K and we have T, so we can calculate the C0, which is representative of C1. So at this point, let's go ahead and plug it in. It's going to be C1 equals 21.9 divided by e to the negative K is given right here, 0.0183 hours inverse. times the time, which will be 16.6833. All right. So once you plug it in, you can go ahead and just calculate it, and it comes out to be 29.7 micrograms per ml. Alright guys, this is all I got for you. I'm gonna link the question in the bio. But if you have any questions about how to do this, what I just did, please shoot me an email, and I'll be glad to help you out. Alright, thank you. I actually did not show what I just did, but here you go, just to know